Our world runs on energy. Energy is the capacity to do work. But where do we get the energy we use every day? Fossil fuels supply most of our commercial energy. Oil, coal, and natural gas are called fossil fuels because they are formed from decaying remains. Crude oil, also known as petroleum or conventional oil, is a black gooey liquid consisting of hundreds of different combustible hydrocarbons, which is also the single largest source of commercial energy in the world. After extraction from the ground, crude oil is being transported to a refinery by pipeline, truck, or oil tanker ship. This is then heated to different boiling points in a complex process called refining, where it's separated into different layers such as petrochemicals. According to geologists, 80% of known and projected global reserves of conventional crude oil will be depleted by 2050 to 2100. The United States uses more oil than it produces. In 2010, US imported about 57% of its crude oil compared to its 24% in 1970. When the rate of crude oil production declines, it is referred to as the peak production for the well. The maximum overall rate of crude oil production is called the global peak production. There's an organization that controls most of the world's crude oil supplies, and there are 13 countries that make up the Organization of Petroleum Exporting Countries. Crude oil, like most things, has its advantages and disadvantages. Oil shale is a rock that contains solid combustible hydrocarbons, which is processed to produce shale oil. The production of shale oil requires large quantities of water, has low net energy and high environmental impact, causing severe land disruption, high water use, and high carbon dioxide emissions. Oil sand, also called tar sand, is a mixture of clay, sand, water, and combustible organic material. Canada has 3/4 of the world's tar sand resources, an amount equal to 7 times the total conventional oil reserves of Saudi Arabia. Heavy oils like oil shale and tar sand also have their advantages and disadvantages. Natural gas, a useful and clean-burning fossil fuel, is a mixture of gases of which 50 to 90% is methane, which also has a high net energy. It's a versatile fuel that can be burned to heat indoor space, propel vehicles, and produce electricity. It's also the cleanest alternative among fossil fuels. Hydraulic fracturing or fracking pumps water mixed with sand and some toxic chemicals to fracture deep rock and free up natural gas stored in there. Drillers argue that fracking is necessary for exploiting reserves at a reasonably low cost, and that there's no groundwater contamination directly due to fracking has ever been reported. There is no guarantee that the increasing use of fracking will not leak and pollute rivers and streams. People who rely on aquifers and streams have little protection from pollution. Major oil companies are partially shifting to natural gas because of the lack of access to the most of the world's oil reserves and the growing expense of extracting oil. Natural gas can be transported as liquefied natural gas. 1/3 of its energy content is used in processing and delivery, thus having low net energy yield. Coal bed methane gas and methane hydrate are potential sources for conventional natural gas. Coal is a plentiful but dirty oil. It is a solid fossil fuel formed from the remains of land plants, exposed to intense heat and pressure. 3 largest coal-burning countries are China, United States, and India. China uses 3 times as much coal as the United States, becoming the world's leading emitter of carbon dioxide and sulfur dioxide. Coal-burning power and industrial plants are among the largest emitters of greenhouse gas. Coal is a relatively cheap way to produce electricity because most of its harmful environmental and health costs are excluded in the market price. The Clean Coal Campaign is a public campaign built around the misleading notion about clean coal. You can burn coal more cleanly by using costly air pollution control devices, but there is no such thing as clean coal. Nuclear power plant is a highly complex and costly system designed to produce steam that spins turbine and generate electricity. A controlled nuclear fission is used to provide heat, and fission takes place in a reactor. The fuel for a reactor is made from uranium, and uranium are mixed from the Earth's crust, then enriched and processed in pellets of uranium dioxide. Pellets are packed into fuel rods, which are grouped into fuel assemblies and placed in the core of the reactor. Light water reactors produce 85% of the world's nuclear-generated electricity, but they are highly inefficient, with a net energy loss of about 82%. A nuclear power plant is only one part of the nuclear fuel cycle, which includes mining of uranium, processing and enriching of the uranium to make the fuel, using it in the reactor, safely storing the highly radioactive waste for thousands of years, retiring the highly radioactive damp by taking it apart, and finally storing its high and moderate level radioactive material safely for thousands of years. Storing radioactive fuel rods presents risks and are vulnerable to terrorist and sabotage attacks. Deep burial in a geologically acceptable underground repository is the safest and cheapest way to store radioactive waste. Terrorists and countries that support the production of plutonium could use them as nuclear weapons. In 1987, DOE announced plans to build a repository for underground storage of high-level radioactive waste from commercial nuclear reactors. Nuclear power advocates contend it will reduce oil dependency and it will reduce or eliminate carbon dioxide emissions. But dissenters claim that nuclear power plants do not produce greenhouse gases, but nuclear fuel cycle does. They also state that increase of nuclear power use will cause dependence on uranium import. Nuclear power is the world's slowest growing form of commercial energy. A 1950s prediction was that by the year 2000, at least 1,800 nuclear power plants would supply most of the world's energy. The nuclear power industry could not exist without support from the government and taxpayers. Insurance companies refuse to fully insure any nuclear reactors. Critics argue that the single most important reason for not building more nuclear power plants is the production of nuclear weapons. Like most things, nuclear fuel cycle also has its advantages and disadvantages. How do we solve these trade-offs among non-renewable resources? Production of energy waste is the quickest, cleanest, and usually cheapest way to provide more energy, reduce pollution, and environmental degradation. Cogeneration combines two useful forms of energy produced from the same fuel source. Recycling materials like steel and other metals is a way for the industry to save money and energy. Switching from incandescent light to efficient LED lighting. One way to include the real cost of gasoline in its market price is through gasoline taxes. Full economy standards for new vehicles in Europe, Japan, China, and Canada are much more efficient than those in the United States. There's an energy-efficient gasoline-electric hybrid car. A newer option is the plug-in hybrid electric vehicle, which can be plugged into an electric outlet and recharged. Building accessible mass transit system within cities, promote bicycle use by designating bike lanes on highways, use of video conference as an alternative to flying employees to meetings. Green architecture is based on energy-efficient and money-saving designs, making use of natural lighting, passive solar heating, recycled wastewater, energy-efficient appliances and lighting. Insulated houses in Sweden uses 90% less energy for heating and cooling than typical American homes of the same sizes. Fossil fuels, nuclear energy, and other widely used energy resources are artificially cheap because of government subsidies they receive, and market prices don't include harmful environmental and health costs. Economics, politics, and education can help us shift to more sustainable resources.